In the name of Allah, the forgiver and the concealer of faults, the guide to repentance, the one who responds to prayers. Respectable faculty members, honorable guests, and distinguished participants, we welcome you all to the 7th International Conference on Applied Zoology 2024 on the behalf of the organizing committee ICAZ 2024 and the Applied Zoological Society of Pakistan. The organizing committee has managed to organize an appealing international scientific event with multiple sessions for you according to your relevant field of interest. I would like to extend my heartiest welcome to our keynote speakers from Turkey, Malaysia, Japan, Iran, USA, and UK. Our today's conference will include 3 oral presentation sessions from multiple fields of applied zoology, including fisheries, wildlife, toxicology, parasitology, nutrition, ecology, biodiversity, entomology, pest management, cancer biology, natural products, nanotechnology, and parasitology. I believe you all will feel enriched with knowledge and innovative discoveries after completion of this great international scientific event. I hope you all will have a very productive time ahead. Thank you for joining us at University of Sargodha and online through YouTube, Zoom, and Facebook. Now, we will officially start our today's conference with the name of Allah. All praises to Allah, the most beneficent and the most merciful. We praise to Almighty and seek His forgiveness. Now, I request Mr. Qasim Naza to join us for recitation of Holy Quran. Please, Mr. Qasim.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم والضحى والليل إذا سجى ما ودعك ربك وما قلى وللآخرة خير لك من الأولى ولسوف يعطيك ربك فترضى ألم يجدك يتيما فآوى ووجدك ضالا فهدى ووجدك عائلا فأغنى فأما اليتيم فلا تقهر وأما السائل فلا تنهر وأما بنعمة ربك فحدث صدق الله العظيم.
Thank you, Mr. Qasim, for such a soulful recitation of holy verses from Quran. खुदा का जिक्र करें, जिक्र मुस्तफ़ा ना करें, हमारे मुंह में हो ऐसी जुबान खुदा ना करे. Now, I request Miss Saira to pay tribute to our last prophet, Hazrat Muhammad sallallahu alaihi wasallam. Please, Miss Saira.
ازل کی خوشبو ہو جس میں پنہاں کوئی بتائے تو نام ایسا وہ نام احمد کے پھول برسیں بیان ایسا کلام ایسا ازل کی خوشبو وہی ہے قرآن وہی ہے فرقان وہی ہے رب جس کا ہے ثنا خوان وہی ہے قرآن وہی ہے فرقان وہی ہے رب جس کا ہے ثنا خوان فرشتے پڑھ پڑھ کے جھومتے ہیں درود ایسا سلام ایسا ازل کی خوشبو وہ جس اندھیری گلی سے گزرے بدل دیا نور میں اندھیرا وہ جس اندھیری گلی سے گزرے بدل دیا نور میں اندھیرا دلوں کی دنیا بدل کے رکھ دی دیا دلوں کو پیام ایسا ازل کی خوشبو ہو جس میں پنہاں کوئی بتائے تو نام ایسا وہ نام احمد کے پھول برسیں بیان ایسا کلام ایسا ازل کی خوشبو
Thank you, Miss Saira, for such a humble and beautiful tribute to our last prophet, Hazrat Muhammad sallallahu alaihi wasallam. Now, it's an honor to invite Professor Dr. Faraj Jabi, the Vice Chairperson of AZSP and the Dean Faculty of Applied Sciences at Government College University, Islamabad. She holds a PhD degree from Qaid-e-Azam University, Islamabad. I request Professor Dr. Faraj Jabi to join us and share her valuable insights with us. Please, Professor Dr. Faraj Jabi.
In the name of Allah, the most compassionate, the most merciful. Dignitaries, national and international keynote speakers, academicians, researchers, esteemed colleagues, honorable guests, and passionate students, Assalamu alaikum. It is a profound honor to welcome you to inaugural session of the International Conference on the Application of Applied Zoological Sciences to Nurture Green Climate and Sustainable Development. Together, we gather not just as scientists and researchers but as stewards of the earth, committed to fostering a sustainable future for all living beings. As we confront the pressing challenges of climate change and environmental degradation, the role of applied zoology has never been more critical. Our discipline provides invaluable insights into the complex interactions within ecosystem, helping us to understand how the health of animal population directly influences the stability of our climate and sustainability of our resources. This conference serves as a platform for collaboration and innovation. Over the coming days, we will explore cutting edge research that bridges zoology with environmental science, conservation strategies, and sustainable development. We will hear from the leading researchers who are pioneering efforts to integrate ecological knowledge into the policy and practice. And we will engage in discussions that challenge us to think creatively and critically about our role in shaping a sustainable future. As we embark on this journey together, I encourage each of you to embrace collaborations, share your ideas, and engage in meaningful dialogue. The challenges we face are formidable, but together we can harness the power of applied zoological sciences to nurture a green climate and promote sustainable development for generations to come. I extend my heartfelt gratitude to the organizing committee, our sponsors, and each of you for your commitment to this vital cause. Let us make this conference a catalyst for change as we work together to protect our planet and ensure a thriving future for all. Thank you, and I wish you a productive and inspiring conference. God bless you.
Thank you, Professor Dr. Faraj Abi, the Vice Chairperson AZSP, for your valuable insights. Now, I'm honored to invite the General Secretary and the Principal Organizer AZSP, Professor Dr. Salma Sultana, Professor and Head of Department of Zoology at Government College University, Faisalabad. Please, Professor Dr. Salma.
I feel privileged to welcome you all at 7th ICAZ 2024 to condemnable Vice Chancellor, University of Sargodha, Professor Dr. Kaisar Abbas, praiseworthy President, AZSP, Patron-in-Chief, 7th ICAZ 2024, Professor Dr. Muhammad Ali, Tagma Imtiaz, Tara Imtiaz, Vice Chancellor, Punjab University, Lahore, Vice President, AZSP, Professor Dr. Faraj Jabi, Dean Faculty of Life Sciences, GCUF, respected office bearers of AZSP and Executive Council members, Patron and Pro Vice Chancellor, University of Sargodha, Professor Dr. Ghulam Yassin, and local organizers at University of Sargodha, Dr. Abdul Chaudhary, our guest from Newcastle University, UK, Professor Dr. Naim Tariq Narejo, Vice Chancellor, University of Baltistan and Skardu, respected keynote, international and national speakers, distinguished participants, consisting of galaxy of international and national zoologists, valued dear faculty members of University of Sargodha, GCUF, and beloved students. First of all, I would like to appreciate all for your expecting presence at 7th ICAZ 2024, organized under the platform of AZSP as a joint venture with University of Sargodha, and for me being a principal organizer and joint secretary of AZSP, it's an honor and pleasure to welcome you all and expecting you will have a wonderful experience and learning moments with us. Stay blessed. Thank you.
Thank you, Professor Dr. Salma, for your productive insights. Now, I feel obliged to invite Secretary and the focal person AZSP, Professor Dr. Azhar Rasool, Professor and Head of Department of Zoology at Baba Guru Nanak University, Nankana Sahib. Please, Professor Dr. Azhar Rasool.
Bismillahirrahmanirrahim. Very good morning to all the people gathered here. Being organizing secretary of ICAZ 2024 and the focal person of Applied Zoological Society of Pakistan, I warmly welcome you all at the 7th International Conference on Applied Zoology, which is going to be hosted by the University of Sargodha. And in this conference for this year, we are focusing on the Sustainable Development Goals, especially the goal number 17 on the climate change, as goal number 13 on the climate change. And for that purpose, we have a very valuable keynote speaker from the different international countries, such as Malaysia, Indonesia, Italy, UK, and Turkey. And we hope that from our keynote speakers, you will have a valuable talks from the topic related to the climate change. And we also have a very good number of abstracts which is submitted by our national researchers, and also we have some national speakers. They also have very good data and very good number of abstracts. So in the coming session, you will have a very interesting talks, and hopefully you will enjoy those one. So once again, I would like to take the opportunity to thanks all the organizing committee members who supported us to make this event successful. So, ladies and gentlemen, sit back and fasten your seat belt and enjoy the day. Thank you.
Thank you, Professor Dr. Azhar Rasool, for sharing your valuable insights. Now, it's time to start our plenary session. I would like to invite our keynote speaker, Dr. Lay Nijithin from the Institute of Research in Molecular Medicine, University San Malaysia, Kuala Pinang, Malaysia. And he will talk about versatile IgG binding protein enhanced biosensor for rapid and sensitive disease detection. Please, Dr. Lee.
Thank you for inviting me for the speaker as a speaker for 7th International Conference on Applied Zoology 2024. Congratulations for the organizing committee for successful organizing such a wonderful conference. Okay, today my name is Lai. I'm from Institute for Research in Molecular Medicine, INFORM, UC Malaysia. Today, I'm going to share with you one of the research topic we will carry out in my lab in UC Malaysia is a versatile IgG Fc binding proteins enhanced biosensor for rapid and sensitive disease detections. So recently, immobilization sensor greatly gained attention from the scientific community due to its ability to perform fast, simple, and reliable sensitivity detection of a wide variety of analyses. It also can be used in the numerous applications including clinical diagnosis, as miniaturizations, screen printed electrodes were used to fabricate the immunosensor by immobilizing the antibody. Previous studies have pointed out that the sensitivity of the assay will be affected by the choice of immobilization method. According to WESH 2017, ideal immobilization strategy means that the immobilized antibody should have a conformation in their native form, orientation that keep the active site fully exposed, a sufficient surface density, and lastly a high stability of the solid support. Currently, there are various antibody immobilization strategy available. The traditional method is done by attaching the antibody via a physical absorption through a secondary bond such as electrostatic interaction, hydrophobic interaction. It is easy to operate, simple and straightforward method. However, this is the last choice to achieve ideal immobilization as the attachment of antibody is relatively unstable and random. Subsequently, covalent coupling and surface modifications have been developed in order to circumvent the critical shortcoming of the passive absorptions. Covalent coupling is a chemical bonding, chemical immobilization based on the formation of covalent bonds between a several function group on the antibodies and substrate surface. It does give a very stable attachment. However, this is complex, and the biological activity of the antibody will be possibly lost due to the distortion of the antigen binding site. The last method is reported to be used the antibody binding protein such as protein A or G as a capture as the capture ligands. This method using affinity interaction between the proteins, it can give a good antibody orientation if no modification of the antibodies is needed. However, this method is not suitable for sandwich types assay as the proteins exhibit the affinity towards the antigen binding site of the antibodies and the other protein molecules such as albumins. In order to avoid the problem, recent studies have utilized a novel antibody binding protein which are human neutral binding proteins, neonatal Fc binding receptors. He showed that this type of method is the study is carried out by Dr. Ernst, a PhD student in my lab before, and the method show efficient in attaching the antibody towards the solid support and show high signal compared to physical absorptions. So the study have divided to 3 different parts of the study, and we're gonna discuss part 1. Okay, we use 2 different type of method for detections. As you notice actually we use a gold electrode, and when do gold electrode they have some incubation and incubation periods for the thing. This is the method, overall method for using. Last part is use the biosensing methods. And the second part actually we use a gold printed electrode, SPE, or we simply call gold SPE. And same thing actually gold working electrode, and we use a link to the potential start, and then we give a 2 type of readings, square wave voltammetry SWV, and the cyclic voltammetry is called SV. So if you notice after the later part of the set, they have the 2 different type of detection. We show this kind of readings. Next we will go for the how we systematic of the sensor platform, how actually we design the platform itself. So this is our in-house. Next usually we have a gold working electrodes at the platform. Then usually we have a surface linker to link the Fc binding proteins. Then after that, this is considered immobile. Antibodies is immobilized by the Fc binding proteins. This is part, and this is the Fc proteins is produced in the lab. After that, we have a biomarker for patient serum, usually about 6-7 captured by the immobilized band. This is the biomarker from the serum side. So this is the systematic of the sensor platform development lab. Okay, next we share for the preliminary study, actually for the functional study, we use the sandwich ELISA assay to prove the concept whether is workable for the developed as a sensor using this Fc receptor. Okay, first actually this is a sensitivity of the thing. We have a platform Fc binding protein. After that, human IgG single domain binding with the Fc. After that, we use a gold anti-human IgG antibody with HRP. Then after that, we have the substrate for it for the detection for ELISA readings. So for the ELISA result, actually you can see that actually this is bar graph compare the binding of Fc binding protein to human numerics IgG1 and IgG2. So we use a different type of IgG1 and IgG2. So the ELISA result reported the binding of Fc binding protein to IgG1 and IgG2. You can see show all this binding. This is compared to the negative, and we have 3 different type of Fc receptor, which is FcGR1A, FcGR12A, and FcGRT actually. And the bar indicate the binding of FcGRT, FcRO. The other name is Fc receptor, Fc neonatal receptor to both antibody was the strongest. Meanwhile, the binding of affinity of Fc gamma R1A is the weakest compared to, this is the weakest among weakest compared to 3. This is the strongest. So it compared to negative, and this is compared to capture of the antibodies. Next, actually we compare to the bar compare the affinity of GG and IgG2 to immunocomplex. Previously we use a monocomplex. Next we use a G complex. The result indicated binding FcGR2A to the human IgG and IgG2 was the increase compared to monomerics. If you can see, all the IgA is compared, is is compared to IG1 will increase compared to monomeric type of bindings. Next, we go to the sandwich ELISA, binding between human IgG1s and human anti-human interferon gamma. So this is considered a preliminary study before we use the human serums. So this is a systematic of the bindings. We have FC binding proteins and human IgG kappa and human interferon gamma. Next, with the coupling with the biotranslated anti-human interferon gamma detection antibody. After that, finally you use the streptovidins HRP, and lastly we use the abstract for detection. So this is the for the sandwich of ELISA. So the results show that the ELISA result indicate the binding affinity of FCGRT of FCIN to the mouse IgG1 was the highest, and FCR1 FC gamma R1 A is the lowest. However, the negative control of FCGRT also showed a high signal indicated the possible of cross-link with the detection of antibody. This is what I mean by maybe a possible or cross-link. So the highest, but there are some maybe possible or cross-linking activity that we will gonna study later. Okay, next we're gonna finish the first part of the expressions or the signal transactions. Next we're gonna finish all the signal measurement and immobilizations. Next we go for the gold electrode, the third part for the measurement using gold electrode surface modification and the quantification analysis of interferon gamma in the solvent solution, and quantification analysis of hemolysin E spike in the human plasma and patient sample. This is gold electrode surface modification interferon gamma. So we use as a platform, we use a histamines as the linker to bind the FC binding proteins. Here we have the binding protein. After that, we attach to human anti-human interferon gamma and human anti-human mouse anti-human interferon gamma and human interferon gamma. So this is a characterization layer by layer for each of the proteins. You can say this is the layers. We show the VOTA monograms, show the layer by layer characterization of electrode surface using the FCGR1A, and this is the same thing also. This is basically show the layer by layer characterization of the electrode surface using FCGR2A. So this show different type of layer. Next, if we have a SMV photometry, show the layer characterization electrode surface using FCGR1A. This is layer by layer. Then you show a different type of photomonograms, and same here. Next, also same thing as this is a characterization of each layer by proteins, and this is same thing using this is using the FCGR2A, and this is the FCGRT. Next, also we have a 6 photomonograms, show the layer by layer characterization using FCGRT. So this is for the selection of potential binding protein. We compare all the three type of protein. All this protein is expressed in the lab, and after that using the mammalian cell culture. Then after we purify it from the lab, and after that this is from the study. And the three different type of the type antibody was studied, and they show that FCGR2A among the most suitable candidate of next type affinity immobilization for the next type of study. So next we optimize the protein concentration of binding interaction. This is FCGR2A, and this is we can show that 400 microgram per ml is the best concentration for the protein binding integrations, while the 800 microgram per ml is show a lower concentration of binding proteins. Show that this is then we choose the 400 microgram per ml. Next, we use same thing. We repeat. Going to use reading of SMV monogram to show the dynamic range of the sensing platform. This is using a different type of concentration of interferon gamma. That you can show that the lowest can go for 100 nanograms, and the highest go for 100 nanogram, and the lowest can go for 0.00001 nanogram per ml. The graph is show the binding protein is very sensitive and according to the protein concentrations. Next, we test the varying concentration of interferon gamma, As they show, the bar graph show that the different of currents increase with the concentration of interferon gamma. This is 0.001 nanogram until 10 nanogram per ml. Next, we need to determine the limit of detections. This is the line graph show the determination of limit of detection. Finally, we have to determine the limit LOD value was found to be of 0.023 picogram per ml. This show that the test is very sensitive until the level of picogram per ml. Next, we're going to determine the coefficient of variation COV. The table is show that the different type of COV in the MWV measurement. Based on the table, the coefficient variation in the MWV measurement will range from 1% here, 1% to about to 10%. Generally, most of the CRV were below 10%, suggesting this sensor is highly reproducible and accurate for detection of interferon gamma. So next, actually, we're going to use a different type of detection, using GO, but using hemolysin. The previous is interference, but this is we use hemolysin E. Hemolysin E is one of the protein marker using for the detection of typhoid. Okay, this is the systematic diagram for the how to do detection. Same thing, we use a cysteamine as the linker, and they have a FC binding protein. Then we use a rabbit anti-hemolysin E, and we use a hemolysin E for the detections. So this is the same. We're not going to repeat it. I think we have to study the layer by layer calculation electrode using the FC1A, FC2As, and FC2A using a Vitromics. So the graph show that the binding is very good and very sensitive towards a different layer of proteins. So same thing is also the result show a different type of characterization of layer by layer proteins, and this show a layer using the FCGR2A, FCGRT, and finally uses FMV voltammogram show the layer by layer correlation. The graph show also very good readings, and it's very sensitive toward when different type of layer were adding to the each type of surface. Next, we will go for selection of protein binding proteins. This is human hemolysin E. Then we can show the FCGR2A is the most suitable protein candidate for the affinity of immobilization, because it must show among the highest compared to other tools. So next we got optimization of protein concentration of binding interactions. Bar graph show that 400 microgram per ml is the best concentration of the protein binding interactions. This is the various concentration of hemolysins. As you can see, is a maximum is go for 500 nanograms, and the next one is the lowest can about 0.0001 nanogram per ml. This is a range, different type of range. Therefore, the result is show that it's very highly sensitive, and if you notice also each layer is usually not overlap with each layer. It means very sensitive, and this is the method is very reproducible and can be a good indicator for duration. So next we're going to produce test with the various concentration of hemolysin E. So the bar graph different concentration increase with the concentration of hemolysin E. As you can see, this is graph maximum we go for 10 nanogram per ml, but the detection still can be taken at 0.01 nanogram per ml. So next, actually, before we test for the human patient sample, next we test the human spikes with the different type of concentration of hemolysin E. So bar graph show that different concentration increase with the concentration hemolysin E. So next with sensor, we will have to detect the limit of detections. The limit of detection value were found to be of 0.161 picogram per ml. So we can show the sensitivity of the test is very high and reproducible. Lastly, actually we want to test on the real human patient sample with a positive semotyphy on the GO working electrodes. After that, you can show that the scatter plot show the result of real patient sample. This is a positive sample with the mean of 51.42%, and we have the difference in currents, and the result of significant difference from the healthy sample is 11.7 so it show a very significant difference. Same thing also, we use a different type of method. We use a gold screen printed electrode with SPE, and the result is show the same type of thing. The scattered probe show the result of real sample with a means of 38.67% in different incurrence, and the result of significant difference from the healthy sample is 14.92%. So these two different type of method by use the same proteins, but it definitely can show that there is big difference among the positive and healthy sample. Therefore, this FC binding proteins can be used for as a sensor for detect. So you can show that both this sensor can be used for FC binding sensor can be used for the hemolysis interference gamma as a preliminary or detection studies. Then it can use as a for the hemolysin E in for the positive seminal typhi for the real patient sample, and definitely it show a clearly different results. Therefore, for the conclusions, early disease diagnosis definitely impacts patient survival and recovery rate. A versatile biosensor platform of employed IgG FC binding proteins have been designed for the detection of various disease. It show that it can be used for the salmonella typhi for the detections. The limit of detection LOD of biomarker interferon gamma and hemolysin E was 0.02 picogram per ml and 0.161 picogram per ml. So it's surely highly sensitive in the range of picogram per ml. The perfect accurate detect a presence of biomarker within a 35 minutes, a very short time and very sensitive, using only 6 microgram of for gold SPE and 7 microgram of gold electrode for patient sample. Therefore, it shows it only need a small type of sample and can be detected within a 35 minutes, which will be very curious. The hemolysin E serum in the typhoid or sample was found to be around 5 nanogram per ml or lower. So we can show that this type of biosensor using FC receptor can be detect a very low concentration of level of protein biomarker within the range of 5 nanogram per ml or lower. Future work can be focused on hemolysin FC binding proteins for other IgG such as IgM or IgA. Consideration of the performance of the sensor stability and the performance for the long-term storage should be evaluated in the future. Thank you for your extensions. So this is my address, this is my email, and this is my contact number. I hope you can, if you can, people who are interested in my research can contact me, or they are willing to have a collaboration in the future otherwise. Feel free to contact me. Thank you very much for your attention. I would like to thank the organizing committee again for their invitation for this. I'm very happy, and congratulations for the successful organize such a wonderful conference in the future, in the current and the future again. Thank you very much.
Thank you, Dr. Lee, for such an astounding talk. Now, I'm obliged to invite our next keynote speaker, Dr. Fatima Quays, Department of Earth and Environmental Sciences, University of Milano, Bicocca, Italy. And she will talk about current waves and future tides, a review of marine-derived neuroregenerative therapeutics. Please, Dr. Fatima.
Good morning, everyone. It's my pleasure to welcome you all to today's conference titled Current Waves and the Future Tides, Review of Marine-Derived Neuro-Regenerative Therapeutics. My name is Dr. Fatima Kias, and I am honored to present this exciting and rapidly evolving field of research. Marine environments are a treasure trove of bioactive compounds with immense therapeutic potential. Today, we will explore how these marine-derived substances are paving the way for innovative neuroregenerative therapies. Our discussion will cover the latest advancements, current challenges, and the future prospects in this fascinating area. The purpose of this conference is to shed light on the groundbreaking research and developments in marine-derived neuroregenerative therapeutics. As we delve into this topic, we will understand how these natural compounds can revolutionize treatments for neurodegenerative diseases, offering new hope and possibilities. According to Silva 2023, preclinical studies have shown that bryostatin can significantly improve outcomes in model of brain injury and neurodegenerative diseases by enhancing these neural repair processes. Research into the broader applications of ziconotide in neuroregenerative therapies is ongoing, with the potential to develop new treatments for neurological disorders. Well, bryostatin is a macrocyclic lactone derived from marine bryozoan. This compound is characterized by its complex chemical structure, which includes a large multi-ring system that is essential for its biological activity. Bryostatin is known for its ability to activate protein kinase C, PKC, a family of enzymes play a crucial role in various cellular processes, including neural repair mechanisms. This activation by bryostatin leads to several downstream effects that are beneficial for neuronal health and regeneration. These effects include synaptic growth and plasticity, where the bryostatin promotes the growth of new synapses and enhances synaptic plasticity, which are critical for learning and memory. Neurogenesis, bryostatin stimulates the production of new neurons from neural stem cells, aiding in the repair of damaged neural tissues. Studies have shown bryostatin can significantly improve outcomes in models of brain injury and neurodegenerative diseases by enhancing these neural repair processes. Now about the mechanism of action. By inhibiting these calcium channels, ziconotide effectively reduces the release of neurotransmitters that are responsible for pain sensation. This makes it a powerful analgesic, particularly useful in managing severe chronic pain that is unresponsive to other treatments. Potential in neuroregenerative therapies, ziconotide has shown promise in neuroregenerative medicine beyond in analgesic properties. Its to modulate the calcium channels can influence various cellular processes which are important for neural repair and regeneration. This includes neuroprotection. Ziconotide, as you know, can protect neurons from excitotoxicity, a process where excessive stimulation by neurotransmitters leads to neuronal damage and death. Survival and growth. By modulating calcium influx, ziconotide supports the survival and growth of neurons, which is crucial for repairing damaged neural networks. Research into the broader application of ziconotide in neural regenerative therapies is ongoing, which with the potential to develop a new treatment for neurological disorder. Repair mechanisms are crucial for recovery from neural injuries and involve several pathways, including the activation of protein kinase C, PKC. PKC plays a significant role in neuroplasticity, which is the brain's ability to recognize itself by forming new neural connections. Neuroprotective compounds aim to preserve neuronal structure and function, particularly in the face of injury of neurodegenerative diseases. As a mechanisms of action, we can set neural repair pathways, including protein kinase C activation PKC, neurogenesis, axonal regeneration. As mechanisms of action too, we can see the effects of neuroprotective, including reducing oxidative stress, inhibiting neuroinflammation, and modulating protein aggregation. Recent advancements in marine biotechnology have significantly enhanced the discovery of the development of marine-derived neuroregenerative drugs. Brother et al. 2021 cited some key technological innovations based on preclinical and clinical studies. Recent studies have provided valuable insight into the efficacy and the safety of marine-derived neuroregenerative compounds. Moran and Thompson 2019 described some key technological innovations such as genomic and metagenomic sequencing, bioinformatics and computation biology useful, marine bioactors, and the nanotechnology. Recent preclinical studies have provided valuable insight into the efficacy and the safety of marine-derived neuroregenerative compounds. These advancements highlight the potential of marine biotechnology to contribute to the development of effective neuroregenerative therapies. Marine-derived drugs offer promising potential for treating a variety of neurological disorders due to their unique neuroinflammation too. Parkinson's disease, including dopaminergic neuron protection, oxidative stress reduction. And finally, spinal cord injuries, including neurodegeneration and scar tissue rejection. Future of marine biotechnology in neuroregenerative medicine looks promising, with several potential research directions, such as identification of new compounds, mechanism studies, optimization of drug delivery, clinical trials, and finally, sustainable production. Well, we explored the significant advancements and potential application of marine-derived compounds in neuroregenerative medicine. The potential impact of marine-derived neuroregenerative therapeutics on the field of biomedicine is profound. These compounds offer novel approaches to treating debilitation, neurological disorders that have therapeutic options. By harnessing the unique bioactive properties of marine organisms, researchers can develop drugs that not only protect neurons but also promote their repair and regeneration. The advances in marine biotechnology, coupled with rigorous preclinical and clinical research, pave the way for innovative treatments that could significantly improve the quality of life for patients with neurodegenerative diseases and neural injuries. More, the sustainable production of these compounds ensures a real-world supply for ongoing research and therapeutic use.